Unidirectional links can cause a lot of problems with spanning tree protocol. What is a unidirectional link, first of all? Well, in order to understand a unidirectional link, you have to understand what a bidirectional link is. This is a bidirectional link. What does it mean? It means that traffic can flow in both directions. Bidirectional. So switch 1 can send to switch 2, and switch 2 can receive from switch 1. Switch 2 can send to switch 1, and switch 1 can receive from switch 2. So that's our bidirectional link. When we're dealing with copper cables, we have our transmit wires and our receive wires all within the exact same copper cable. So it's really hard to see these different links or wires that are being utilized when we're dealing with copper. But with fiber, you have a fiber strand that is being utilized for one direction, and then you have that other fiber cable that's being used for the other direction. So we could have a unidirectional link with fiber really easily by accidentally cutting, crimping, destroying one of the fiber cables in that pair. However, with copper, it's not as easy. But think about it this way. What if, for some reason, a couple of the cables get pinched within the cable, or the pins within the ports, or the pins on the RJ45 connectors are damaged? Then you could theoretically have a unidirectional link where traffic is only flowing in one direction. So you might be saying right now, so what, Raymond? What's the big deal about this unidirectional traffic flow? Well, spanning tree protocol doesn't like it. Examine the topology on the left-hand side. Everything is good on the left-hand side. So far, we have our root bridge up at the top. And all the ports that need to be in the forwarding state are currently in the forwarding state. And we have our blocked port on switch number 1. So what is happening here is that there is no loop within the topology. The loop is contained right now because of that blocked port. But what is the blocked port expecting? The blocked port is expecting BPDUs every 2 seconds. Every 2 seconds. What happens if the blocked port stops receiving BPDUs? How long will it wait? It'll wait for a grand total of 20 seconds, which is the max age timer. And then once that max age timer expires, the blocked port goes through the listening state, then the learning state, then the forwarding state. So what might cause switch 2 to stop sending BPDUs and create a unidirectional link in this case? You know, what if this cable gets completely cut? Well, if it's a copper cable, no big deal, because all of a sudden it doesn't exist at all, so we don't have a loop. But what if the cable is still there, as we see on this side? It still exists. Or what if in a fiber pair, just one of the cables gets cut? We theoretically still have a connection. And traffic can still flow in one direction, unidirectional. But what else? What if spanning tree protocol fails on switch 2? What if it's not working as it's supposed to and it stops sending BPDUs out that interface? Then technically speaking, we have a unidirectional traffic flow or unidirectional link for bridge protocol data units. They're only flowing in one direction now. So since the BPDUs are no longer received by this interface, it goes to the forwarding state. And when it goes to the forwarding state, because this is still in the forwarding state, because when spanning tree protocol fails, how does it fail? It fails open, meaning that all the ports go forwarding. So now what do we have? We have the loop you see here. So the unidirectional link, whether it's caused by software failures or whether it's caused by a hardware failure, a physical link failing, is detrimental to spanning tree protocol. And we need a way to recognize these unidirectional links. And there's features such as LoopGuard that can help us out, and features such as UDLD.